Welcome to module 12 of object oriented analysis and design. In the last module, we have discussed about the nature of objects. We have noted that an object is typically characterized by its state, its behavior and its identity. So, with that we are now ready that in our system we will have identifiable objects, as many of different objects as we need to, and each object will have its states which can be in terms of static properties and dynamic values, and each object would manifest the different behavior for providing services to other objects, and they will interact to build up the system. In the current module, we will talk specifically about relationship between objects. So, our objective in this module is understanding the relationship amongst objects. This is the module outline. As usual, this will be visible on the left hand side of every slide. So, we will proceed according to that. In terms of relationships of objects, the point that we note that in the whole system we will have several different objects that would exist, but the object, one or more object in isolation, does not provide any interesting system, is not an interesting situation to analyze or design. But when the objects come together, they get interrelated, they get associated, linked in different ways, then they start showing really interesting properties, they start giving capabilities which are critical for the total complex system that we are designing. Say for an example, here I just show an aircraft. This is, as you can see, this is the whole of the aircraft, and it has different component objects. So, the cockpit, the engine, the wings, two sides, the fludder, the slates and so on. So, several different objects exist in the airplane. Now, if we look into these objects individually, they themselves have some complex behavior, but they each by themselves do not really achieve anything till we put them all together, connect them all together into a single airplane which can fly and carry people. So, the relationships primarily has to talk about how the objects can get interconnected and behave between themselves. In terms of object oriented paradigm, we talk of two important relationships for objects. One, that are called links, often they are also referred to as associations, and the other is aggregation. So, first let us talk about links. A link is a physical or conceptual connection between objects. So, I may have two objects which are physically connected, like I have just talked about the airplane. So, the cockpit, the body, the engine of the aircraft are physically connected. So, they are linked, or there could be conceptual connection between two objects. I am an individual. So, I may be described in terms of an object which has a name, date of birth, designation, affiliation and so on. I have a bank account with some bank, where my account has the account number, the type of account, the transactions, the different account balance and so on. So, there is a relationship between me and my account. This is also a kind of link, but this link is kind of a conceptual in nature. There is no physical link between me and my account, but certainly I am related to my account is related to me. So, that is the basic notion of links. An object collaborates with other objects. So, we say this in formal terms, an object collaborates with other object through its links, and these links, if we refer back, recall our basic model of object oriented systems. The model is the client server model, where two objects, one need a service and the other which will provide the service, the one which we call the client which needs the service, and the provider, the server object, will pass messages between themselves to achieve what is required. So, links necessarily show that where the messages can pass from one object to the other. It could be a use kind of a message, invocation kind of a message, or application for service kind of a message, or it could be just a navigation from one object to the other. So, link basically is a representation of the interrelationships between two or more objects. In this, links are more often depicted in some graphical notation, and we will start introducing this, and slowly we will see at a later point that refinements of this notation will result into our unified modeling language diagrams, the UML diagrams. So, here we are just starting with a very simple notation, where I have one object which is just written shown as a rectangular box, there is another object and there is a link connecting them. So, this says that there is a link, there is an association between object A and object B, and in this case please note that there is a direction given. So, it is the link is directed one. So, it says that object A can ask object B to provide a service. So, the object A can pass a message or invoke a service that object B provides. So, that is done in terms of sending the request message from object A to object B. And so, there is two kinds of directionality that is involved here. One is the direction of the link, which shows who is requesting, this object is requesting and this object is responding. And then on top of that we are showing the direction in which the message goes. Certainly, the client object who is requesting has to send a message to the server object. So, that direction is same as the direction of the link. Now, in some cases the receiver object or the server object will need to send back some result or some response. So, there could optionally be a message which goes in the reverse direction of the link as well. So, on one side the link shows the who is the client and who is the server, who is requesting and who is serving. The message direction on that could be in the direction of the link, that must be there because that is how the request is made, but there could also be bidirectional flow of messages over a particular link. So, with this let us look at a very simple example. So, this is we are talking about a flow control system which has three objects. There is a valve. So, it is basically the application is like this, possibly there is a pipe through which water is flowing and that flow needs to be controlled, that you can increase the amount of flow, you can decrease the amount of flow and so on. So, the object through which you do that is called a valve, and certainly there is an object which we model here as flow controller who decides as to how much flow will happen. So, that controls the valve. So, it can adjust the flow that is happening. And third, we are also talking about a kind of object, say like a display panel, where we can see what is the current flow that is happening. That is kind of a simple model. So, you can think of this, I am specifying this in terms of a flow control system. The similar thing you will find in terms of the electrical meters that we have at home and so on. So, if we look into the specifics of this, so it has three objects as I have already mentioned. The flow control object has a link to the valve object. I am talking about this particular link. And the direction of this link says that the flow control object can send messages to the valve object. So, these will be messages like adjust. So, the flow control will say that you adjust, you increase the volume, decrease the volume, you can increase the volume by certain number of units and so on. So, the flow control object, the link from the flow control object to the valve object shows that this can work as a client and ask, while this works as a server, ask it to adjust the flow. In a different way, there is a link from the flow control object to the display panel object. When the flow control object has adjusted the flow control object could send a message to the display panel to say that you display that this is going to be the flow that is going to happen. Or it could also be that the flow control sends message to the valve saying that this is the adjustment, and then valve, as it gets adjusted to the new flow, sends a message to the display panel and shows that message. So, this link shows that there could be a message from the valve to display panel as well. So, this is the basic way to show how different objects can be linked between themselves. So, if we look into the messages that exchange, the flow controller invokes the operation on the valve object. Here again, please note that the message can be bidirectional because it is requesting the valve to do something. So, say if it is adjust, then possibly the flow controller will simply say okay, adjust, increase it by 2 units, decrease it by 3 units, something like that. But suppose it wants to send a different message to the valve object saying is closed. So, it is trying to check if the valve at all is working or it has been closed down. So, naturally the flow controller now in this case expects a response back from the valve object as to what is the state of the valve object. Is it flowing or is it closed, it is stopped. So, even though there is a single direction where it is sending the message is closed, it will expect a message back which will say maybe say true or false, something like this. So, the message flow in this case could be bidirectional. So, on a single link of one direction there could be multiple directions of messages that can ply between them. Now, we also characterized. So, this is we just took a look as to how the messages can flow, how that we depict in terms of connecting the objects through links. Now, from this linked diagram of message flow, we can talk about what is the role that these participating objects play in terms of a link. So, some objects like the flow controller basically sends out messages to others to get some service, whereas it by itself the flow controller does not serve anyone. So, such objects are known as controller objects or active objects. They kind of control the system, they kind of drive the system. We will see more specifically as to what is the definition of active objects, but what characterizes flow controller in this case is a fact that other objects do not operate on it, but the flow controller operates on the valve and the display panel. The display panel on the other hand does not operate on any other object. It does not ask for service from anyone else. It will just provide service to others. That is, whether the flow controller asks it to display some information, whether the valve asks it to display the flow rate, it will comply and display that. So, such objects which only provide service are known as the server objects. And if we look at the valve object actually does kind of both. It provides service to the flow control because it can receive message from the flow control to adjust the flow, to respond to flow control as to whether it is closed or open. At the same time, it could send requests to the display panel to display the state of the valve, to display the amount of flow that is happening in the valve. So, these are kind of objects which at the same time can operate on some other objects and can be operated by other objects. Such objects are known as proxy objects. So, we see that we have primarily three roles: the controller or active object role, who only asks for services. These are commonly called clients. We have server objects who would predominantly provide services to others without asking from service from others. These are known as server objects, and proxy objects are kind of mixture of them. The identification role we will see later on would help us in actually finding out how these different objects should be implemented. The next parameter that we need to need to know is that the objects also has visibility factors. For example, the flow controller has to send a message request to the object valve. Naturally, that means that the flow controller must be able to see the valve object. Flow controller must know where the valve object exists, and it should be able to send that message. Visibility basically means that whether it can actually send the message, whether it can actually send the request. So, it is important that between the objects, the links alone will just say whether there is a possibility of sending a message, but we also need to make sure that in the whole pool of objects that exist in a system, there is proper visibility between them. And there are four types of visibility known by public visibility, package visibility, protected visibility, and private visibility. We will not elaborate on this a lot here, but we will come back to this in a later module after we have discussed about the classes of different objects. The next concept in connection to relationship amongst object is the concept of synchronization, and this is a concept which you need to understand very carefully, because this is little different from the typical programming concept, where we know that we have written a code and we start executing it. If we have written it in C or Java kind of language, then we know that there is a main function from where the execution starts. Different functions are called, and when the task is over, this particular main function terminates. But in terms of a object oriented system, when that comes into being, please remember that we have multiple objects. So, if we try to kind of look at the model, we have multiple objects. I have drawn similar figures very often. We have multiple objects, and the objects are sending messages, they are sending post back response and so on. So, what we need is, when object O1, who is the client, is sending a message to object O2, then both object O1 and object A2 must be in execution. That is, unlike the typical programs that you may have written and executed earlier, which are called sequential programs or single threaded programs. Here we need different executions happening associated with different objects, because in the time when O1 executes, O1 is doing its operations, at the same time O2 will have to do its operations as well. So, these are typically called distributed systems or concurrent systems, to be more precise, and whenever you have that, there is a need for synchronization, because if two threads or more threads are trying to work on the same objects or the same set of objects, because there are different objects running on them, then there is always a question of issue of whether the operation will be correct, whether the operation is performed in the right way or not. So, we will soon discuss an example to illustrate this further, but before that let me introduce two different types of objects in the context of synchronization. They are called active objects and passive objects. An active object is, this is the definition, an object is which instigates an interaction in a thread. That is what it simply means, that an active object by itself will decide that something needs to be done and will start doing that. So, the thread on which the active object runs will by itself change its state, and for doing whatever it needs to do, send message to other objects. Naturally, they are responsible for handling control to other objects, because they are deciding what needs to be done. In other terms, we will call them as clients, right. Maybe some of you may have had the situation to deal with the client situation, where the client is subscribing to a project, pays you for the project, and you have to provide service to the client. Naturally, you know that you do not decide when things will happen, how things will happen, the client will decide that, and based on that you will have to react. So, concept of active object is very similar to that. In contrast, passive objects are passively waits for messages to be processed. They by themselves do not start doing anything, they by themselves do not change their state, they are just in threads which are just listening if the messages, if there is some message from a client that is arriving. So, they get activated when they receive a message from another object. So, in this process, once they receive the message, they know what service needs to be provided to the client, they just provide that service, and accordingly the states of the passive objects gets changed by what the active objects send messages to them. So, these are known as the server objects. So, given that there are different situations that need to be synchronized. Yes, now, I just mentioned that we need to understand what is synchronization all about and what could be the issues. Let us take a situation which I am sure many of you, if not all of you, would be familiar with. Suppose you are working in an organization or in your college, there is a printer which is connected to the network. So, I have what I have is a printer, this is a printer which is connected to the network, this is a network, and different computers are connected. C1 is one computer, C2 is another computer, C3 is another computer, which are all connected to the network. These days we always have computers connected on the LAN or the Wi-Fi and so on. Now, in these computers different independent people are working. So, they decide to send files for printing to the same printer. There is only one printer. So, let us assume that he has requested to print file 1 and C2 has requested to print file 2 at the same time. File 1 has, let us say, file 1 has say 10 pages, this has say 20 pages. So, both of these requests arrive on the object print. Now, you will understand that certainly every page of the file that needs to be printed must be printed in a consistent manner. Certainly, you do not want that you print 2 pages of file 1 and then 3 pages of file 2, or if you are doing back to back printing, the situation can get even worse. You on one face you print a page of file 1 and in the back you print the page of file 2. You would like to avoid that, but the requests have come together and the requests will need to be served by the printer at the same time. So, we need to make sure that even in this situation where C1, the computer 1 requesting for the printer to print file 1 conceives as if the printer is exclusively available to C1. C2 at the same time requesting the printer object P to print file F2 also thinks that the printer belongs only to C2. C3 for now is not printing, but C3 also thinks the same way. So, we need to make sure that in this context things can happen correctly. That is, all these requests should not get mixed up. So, the process by which we make sure that these printing tasks of printing file 1 and file 2 could be done in some way, they can come in, the request can come in any arbitrary order, but they must be serviced in a certain order, so that the result is consistent, which means that either I print file 1, complete it, then I print file 2, or I print file 2, complete it, and then I print file 1. Or if the request to print file 2 comes when I am already printing file 1, that request will somehow have to be put aside till I am finished with printing file 1. So, this what we need to do, this is known as, in terms of concurrency studies or in terms of synchronization, this is known as mutual exclusion. Mutual exclusion means that if there are more than one request which need to be serviced by the same object at the same time, then they will be serviced in certain serial order. That is, the two requests will have to be mutually exclusive. Certainly, also please note that not all requests need to be mutually exclusive. For example, if I have a value in a variable, if an object has a value and two other objects send requests to read that value, that can happen simultaneously, because it does not matter how many times you read a value from the same variable location, you will get the same value. But the situation will require mutual exclusion when you need to write that value at that place. So, that needs synchronization, that needs mutual exclusion to be put in place, and there are three basic strategies to do that for concurrency. One is sequential, where there is a passive object that is providing the service and it is linked to only one active object. So, the object decides when it is to send the request to the passive object, and therefore, passive object has nobody else, the passive object will service. So, in the context of the example we were talking of, that means that you have a PC and you have a printer, your printer is directly connected to your PC, there is no one else. So, I can the print task, the active object can use the printer object, the passive one, directly, which is like this situation is like a function invocation. So, that is, this is as if the calling function and this is the called function. This is the simplest situation of synchronization, which is sequential. The second could be what is known as the guarded concurrency, where what it does is the requesting object, the active object, the print task will know that well there are multiple files to print. So, what it means that the computers will C1 and C2 will not send the request directly to the printer, but it will send it to another object, say a print task or print manager kind of object, which having received two requests can make some kind of a queue between them based on the arrival and then send them one by one to the printer. So, looking from the passive object printer, it gets tasks one after the other, whereas the print task, which is the active object, which is actually received the request, is managing how to put multiple requests in a serial order. So, this print task is basically providing the guard that two requests will not lie in the printer at the same time. So, this is a situation, a guarded concurrence is a situation where the invoking object or the client object manages the mutual exclusion. And in the last case, it could be that if you are aware, most of the printers these days have a internal mechanism to queue up requests. These are called print spoolers. So, it could be that your printer is advanced enough to have a spooler. So, it does not matter, the passive object printer could be given two requests at the same time, but it will internally do a spooling, it will internally do a queuing and manage the sequencing of the two requests. So, this is a situation where the invoked object, in this case the printer or the server object, actually manages the mutual exclusion, and the multiple print task could just blindly shoot print requests to the printer. If this situation exists, then we say it is a situation of concurrent access. So, we have seen three kinds of concurrency: sequential, guarded and concurrent.